Okay, welcome then to this talk. This is about IPFire 3, well, the first proper talk about the next generation, and this one focuses on the networking. So what you'll be hearing is just a very short introduction, I hope, about the basic network functionality. There's nothing, well, too new there. That's still the same kind of networking, you know. What we have a new set of tools that is was written and integrated in IPFire 3, the current alpha version that we have now. And I'm just going to show you this this new code. It's still a bit in the alpha state. We'll probably get into that, but what's this all about? The main thing that we have is the network command. So this is the command to do everything. We don't have this in IPFire 2. There's nothing central, no central tool that you can use to configure your networking. We have configurations in all bits and places, and we have different scripts that take care of different types of network zones that we have. If you have a dial-up connection with a PPP, OE, it's a completely different set of scripts that is used instead of DHCP. So this one is just all one big thing. So that's very helpful because we can reuse code. It's all at the same place. It's easier to use it. You don't even need to remember what kind of zone this will be. I will explain the zone thing a bit later. But we have all in one place. So the motto of that is want to rule them all. We have rewritten that from scratch. So there is nothing except some concepts that have been transferred from IPFire 2 to IPFire 3. But everything code-wise was just dropped and then rewritten from scratch. It's shell code. So the old code was shell as well. It was not very easy to maintain, and shell code is probably not the fastest type of code you can use, but it's very easy to extend. So we are an open source project. I wanted to use something that everyone is able to use and extend. So writing that in C is probably a bit of a better decision in technical terms sometimes, I don't know. But shell does the job just as well. It doesn't execute that fast, but that's not really an issue here. It's fast enough. So I put fast on the slide. It's fast enough. That's what I mean here. So, and then there is no patchwork in that. That's the other reason why we just rewrote is the old code. You all have seen that, I think. It's really, really complicated. It's very complex. It's messy even. Maintaining that is a hell, really. So if you change anything, you sometimes break other things that you don't really think of, and that shouldn't happen. So this is just, a new concept, just clean code. With all the new code, there come some new concepts. So everything is new, really. So there are some interesting things. If you read through that, I'll explain them all one by one now. It doesn't all sound too fancy, but if you think about it a couple of minutes, it all makes sense, and these things are all must-haves in a way. So at first, it just initializes everything in parallel. So if the system comes up, everything of the network is brought up at the same time. At the moment, with IPFire 2, it's just one zone after the other one. If there is no internet connection because it's just down, or if you have some sort of a mobile connection where you need to initialize the SIM card first, that all takes time and delays the boot, and you can't do anything in that time. So this will do everything in parallel, and that will be a bit faster. And it doesn't block if there's an error on one of the zones. Kind of related to that is that everything is hot pluggable. So if you plug in a USB adapter, it just comes up. So you need to configure it first, obviously. But if you have a Wi-Fi adapter, if you have an Ethernet adapter, or even LTE or 3G connection, you just plug it in and it comes up if you configure that. So This, yes, sounds a bit like a fancy feature, but I think it's really necessary because you want that on virtual machines. You don't want to reboot the entire firewall just if you change something in the network configuration. At the moment, you just change the configuration, the entire network restarts, and you drop your connections, and we don't want that anymore. So, sounds a bit like the old days, like the plug and play days, but I think it's a very essential feature that we have here. Then we have auto completion on the command line. I'll show that later in a demo. That's just a nice, user-friendly feature, because sometimes it can be a bit complicated to configure the networking, and we just can press the tab key twice, and you can see a set of all the available commands. So you don't have to remember that much. Then I already got into that. We kind of want to keep it easily extensible, so that's why we picked shell as the common language. I think every admin in the world is kind of familiar with that. It's a modular design. Everything is built around zones and hooks that I will show to you shortly. And there is a huge library for literally everything, so you don't rewrite things like assigning an IP address on an interface that is already taken care, so that we can rewrite stuff later if we need to. We can optimize easy things, and we don't want to copy any code. That's why we have a good library. So at the moment, this is all in some sort of an alpha state. I think it works quite well, but there are still bugs. So sometimes if you don't configure everything as expected, it could break. We changed a lot of stuff, so it could break, and testers are welcome. So zones. We have different things. We have zones, we have ports. The zones are the logical part of the network. So a zone is what we call the green network, or the blue network, or the orange network in IPFire 2. We remove the colors in a way, because at this level it doesn't make any sense. I'm not really sure how much sense that will make later to reintroduce the colors, but at the moment we just have these zones. We have unlimited ones. So you can't just have one green, one blue, one orange network, and of course the red one. You can just have 2, 20, even 50 green networks if you need that. So this is one of the most important things, I think. In the future, we'll have the Internet of Things, and Daniel already is experimenting with that, dividing the entire network you have in many very small zones. Just put singular devices in that, so you're able to block them. So you don't want them to communicate to each other. You just want to provide the basic internet connection and nothing else. And that's what you can do with that. You can also divide a huge network. Well, if you have some sort of a school, you can have a network for each classroom, whatever you fancy. It's all possible. I already said that it's a logical segment of the network. Zones are not always physical, so you can have different ones, like just virtual ones. There are two different types of zones. There are uplink zones and network zones. The difference between those two, is nothing except the names and the purpose of that. Technically, they all work the same. You just have, for your normal networks, it's not called green 0 anymore. It's just called net 0, net 1, and so on. And for the red ones that we have in IPFire 2, you call them uplink zones now. So in that sense, you have your local network zones. These are just local, or maybe these are VPN zones. These are the virtual kinds. They are all the same, all the network zones in that sense, and they are uplink zones. These are the ones who have a connection to the internet, or some router that knows the way to the internet. So we just need to make this distinction later if we run a DHCP client. So it doesn't make any sense to run a DHCP client on net 0 maybe, but it certainly makes sense to run that on UPL 0. To put on different kind of zones, we have different approaches. So there are hooks. Zones can be quite easy, like bridges, where you have one or two network adapters and just connect two physical parts of the network. That's what we call a bridge, but you can also have a dial-up connection or something else. So we don't even know how these connections will work in the future. So we have this hook concept. It's just a sort of plug-in that you can add or you can edit. And if there is a new protocol coming up, you just can write a new hook, and that's it. So you can have a zone kind of inherit all of the concept, and just implement your physical bit, maybe, to connect to the network. I'll show you some hooks soon, so I think it will all make sense. The basic idea behind that is just that we want to keep this modular. So if there's a new technique coming up, we want to be able to extend our code. The only requirement in the end is that you have some sort of a Ethernet-like device. So that's a term from the kernel. Some connections don't really transport Ethernet frames. Of course, the normal network adapters do, but not a dial-up connection. But they also have Ethernet-like devices, like the P0 device. It's just one emulated device. That's all we need, and we need to be able to assign an IP address to that, and that's basically a zone. Let's go to the first example, and I think that will be quite clear after that. The most important one is the bridge hook, because everything will be a bridge. So we have that because you want some certain features. The first thing is redundancy. What you can do is you have a bridge and you put two or more physical network interfaces in that. So you can bridge, quite literally, certain parts of the network. And you can have even a switch. So you know that from the simple hardware routers where there is just one zone, but you have 4 ports where you can plug in your devices. That's what we built there. We can't do that at the moment. Some people do that. There are scripts on the forums, but that's quite complicated. And we thought, okay, it makes sense to keep everything as a bridge. Even if you don't have more than 2 devices or more than 1 even, you can just put 1 in that and it works just as well. And at the same time, if you have a bridge running, you can add more devices whenever you want without breaking any connectivity. And that's quite important. So packets are forwarded between these, so it doesn't always make the way through the firewall. That's not the job we are doing there. We gain redundancy if you have 2 switches. You know that, I think. You can put in 2 NICs and connect them to different switches, and you get the redundancy if one switch fails. And you get more performance. So if you have a big network or 2 parts of the big network, you get a gigabit maybe to each part of that. I already mentioned that you can add network segments at runtime or remove them, of course. What else we can do is we can have true layer 2 VPNs. It just works the same way. You have the bridge, you put a virtual VPN device like the TAP device into the bridge, and you just connect that to some remote site, do the same thing there, and you have a true layer 2 VPN. It's just one of the advantages that comes with that too. And that's how it all looks. So on the command line, there is the network tool, and that's what you get when you just display the status of the zone. It's probably a bit like the IP link output, just a bit nicely formatted, I hope. So what we have here is the name of the zone, which is called UPL0. It's enabled so that it will start at when the system is coming up, and is a bridge. So it's currently up. There's some details about the MTU, and I think there will be more stuff coming there. You have some information about how many packets have been transferred so far, how many megabytes that is. We also use spanning tree on all of the zones, so if you have a loop in your network, that this will be will convert it back to a tree. And there are ports. So in this zone, there are 2 ports connected. These are the physical things. I'll explain in a bit. And these are forwarding. That's the spanning tree terminology. There's also a IPv4 DHCP client running on that, and it got this IP address assigned. So this is all the information in one glance. Quite quickly, the other ones. There's of course the PPPoE hook. You know that from the dial-up lines like the DSL, VDSL, whatever it's called. Some area connections or satellite links, they all use that. And it works kind of the same. So you have this zone, you have a port that is connected to this provider. So that could be like an Ethernet device or USB device. You never know, really. It doesn't really matter as long as it just is emulating this Ethernet-like device. And yeah, that's how you do that. Quite similarly. And in that way, we can have like different hooks for different connections. There's also the modem hook. The way you establish a connection to your provider works still like back in the day where we had 56K modems. So it's not different at all. If you plug in a 3G stick, like a USB stick, it just emulates a serial connection. It doesn't have 56K anymore, obviously. It's a bit faster because it's using USB. But the way you establish the connection to your provider is still the same. So there's the modem hook that supports 3G and 4G connections as well as 56K. I'm not really sure, we haven't tested that. I'm not really sure if we should support that even. But it's there and it just creates a PPP session over a serial link. That's it. Then there's a wireless hook. It just connects to existing wireless network. So if you put an IPFire appliance somewhere where there is like no cable connection, you just type in the credentials and it will connect to the wireless network, just like that. It's called the Wi-Fi client, I think, in IPFire 2. It's essentially the same thing. And there are some others which didn't qualify for an extra slide. We have some IPv6 transitions protocol mostly there. That's things that help you to connect to the IPv6 internet via different technologies. I'm not really sure if you have heard of any of them. I think if you have read about IPv6 transition, you have heard, I think, of all of them. We do support these. I think they will be, they will go away hopefully quite soon. But for the moment, we have them and we will still support them. So what have we seen? Let's just conclude that quite briefly. We support everything that we have in IPFire 2. It's just called differently. It's still the same. So we also have Wi-Fi connection, like the DSL connection, obviously, in IPFire 2. There's nothing new here. It's just implemented in a very different way. It's more modular. I think it's more easy. It should be more logical for the admin, just because you have zones and you can change them without breaking anything. That's how that works. What we don't have is PPTP. That's an older dial-up connection type that was used in Austria, maybe in Russia a bit. We just decided to not support this at the moment because we can't test that. And so that's that. It might become back later. So if anyone is able to test that and sending in any patches, we can just write a new hook, put it in, and then we can support more. The next thing that you need to know about is ports. This is where the physical network is coming in. So we have a logical network, which is a zone. And I like this classroom example, by the way, I just made up. So you can have multiple zones, but now you need to get some sort of a connection to this classroom. That could be on a different floor. I think the firewall is usually somewhere in the server room, and now you need a port to connect just to this network. If you have a classroom or two, that works quite easy. You just put in physical network interfaces. But if you have 10, 20, maybe 50 rooms, it gets quite complicated. And that's why we have also the possibility to add virtual ports. So they all have something in common, that is they can connect to a physical part of the network. But that could be a bit virtual if you use VLANs. So if you plug in a new Ethernet adapter into the system, that could be physical, it could be virtual, it could be USB one, which is the most obvious case. You just plug it in and it is getting configured automatically. So what we will see is some basic information that you can get on the console. If you type in network port P1, that's the name of the port, status, you get the status, which is up in this case. You get the MAC address, MTU, if it's in promiscuous mode or not, and some statistics, as well as link rates, where it is connected to, or if it even has a connection, these sort of things. So these are created automatically. The virtual ones are obviously not. So that's why we have hooks for them. So there's the VLAN hook, which just creates a VLAN device. I think everyone knows about VLANs, right? Okay, so you just need to type in some things. I'm not really sure if I'll show that later in the live demo. I think it's quite obviously. So if you type in network port new VLAN, you just create a new port of the type VLAN, and then you need to add some basic information, like what is the parent device, that is D1 in this D0, sorry, in this case, and you need to add the VLAN tag, which is just 10. So, and then it just creates a new configuration file with all these settings, and then you need to bring the device up, and then you'll have a new virtual device that is kind of sending or transmitting packets with the VLAN tag 10 on the D0 device. And it all, well, the information you get there is all the same like before. So at this level, if you just create this device, it's completely the same. It doesn't even matter if you are working with a virtual one or a physical one. That's how these tools work. They just put an entire layer of abstraction to that. We don't have that in IPFire 2 with the VLANs yet, not really. Then there's the other way around, where you just have one physical network, but you want to connect multiple Ethernet adapters to that. So that's called a bonding device in our case. It's also called trunk or lag or bond, depending on what kind of switch you're using. It just works the other way around. You have two network adapters, put them together, you get failover, you get redundancy, and of course more throughput if you can use LACP, the protocol. So it's all the same here. You type in network port new, bonding B0, that's the name of the bonding device. Put in the slave devices, which is D0 and D1 here, and then bring it up again. This is just a virtual one where it says no carrier, so there's nothing plugged in there, but it's all the same again. That's how ports work. So there can be different types of ports, but they all look the same on the logical layer.
Is there also the possibility to specify the bonding mode, or?
Yes, it is. So in this case, it's LACP, but you can also have just round robin, this hashing type where it depends to which IP address you're connecting, or just sending the packets on alternating links. So first packet on the first one, second on the second one, and then third on the first one again, and so on. Yeah. So that's all supported by the Linux kernel, really. We don't do that much here, just our configuration. So everything that's supported in the kernel is also supported here. Okay. So then there's the wireless AP hook. AP is short for access point. You know that. It's essentially the same here. apparently there is the old output from the bonding here. Oops, sorry. Yeah, what you do there is you can have multiple access points on a single wireless adapter. So if you use a USB device and you plug that in, it could create multiple access points, and we can do that here as well. What you get is a new virtual device. You can call that AP0 or AP1 and so on, and can put the one in the first zone and the other one in a second zone, so that you can have different wireless networks all connected, all working with the same hardware, but logically separated for better network separation and firewalling. There are also some smaller, less important hooks. You can also have wireless ad hoc devices. That's probably not really that much used anymore, except for these wireless mesh networks, like the Freifunk project, if you have heard of that. We also can create dummy devices. I use them just to show in this example how the bonding hook works. These are quite useful if you need just a zone that is more than empty, if you need routing that goes just into nowhere. There's certain cases. Also for testing, the dummy device is quite handy. And we have the Batman device, which is just the implementation of this Freifunk idea. We kind of tried to work together with the Freifunk guys, but that didn't work out in the end. But the code is still there, and it doesn't make any sense to drop that because it's been developed. It's quite easy. Probably not many people will be using that. Well, yeah, that doesn't matter. So in the end, we have to put this all together. So you have to connect zones to ports, and we call that attaching and detaching. A port is getting attached to a zone or detached from a zone. There are a few easy commands here. I'll show them quite quickly. I created a new bridge zone here with the command network zone new net9 bridge. Then I typed in network zone net9 port attach B0 and network zone 9 network zone net9 port attach D0 V10. So D0 V10 and B0 are physical network interfaces, so ports as we call them, and you can just type in these commands. They will get attached and brought up immediately. So in that case, you can plug in an entire network segment quite seamlessly. Okay. So, and there's another box here. So in the end, you can say, if you print the status of the zone, that there are 2 ports here. B0 is still not connected to anything, so it says no carrier, but the other one is connected, and so it says forwarding here. And that's how these 2 things work together. Also, try to paint a little picture just to make this clear. So net 0 could be a zone with multiple ports in them, and there's the naming scheme again of the ports is a single port. A simple one is called P0 or P1, P2, P3, like these. If you plug in a new device, it will be P4, like that. But we have special names just to make clear that there are special devices. So bonding devices are called B0, B1, and so on. Wireless access points are called AP0, AP1, and so on. And the dummy devices are called D0 and so on. So it doesn't make any difference what they are called. We could call them something different. This is just easy to remember and also easy to type, where if you would call them port, like all the letters written on L bonding, it's just quite complicated to type, I think. So I picked very short names for the ports, and the zones a bit longer. So you can also see what is a zone and what is a port just by its name. So here we have a bonding device that has 2 physical network devices attached to that. So that's what I was trying to show here. Again.
And so the names are predictable if I have first put them in, and maybe a virus device gets the device name AP1, 2, 3, whatever?
Not automatically. So if you plug in a new device, you need to set up some sort of configuration. You need to tell the SSID and maybe a key if you use encryption. But these also get predictable names. You can pick them or you can change them if you want to. But also by default,
What I want to know is what happens if I put it then maybe 1 year later in another USB port. Does it get the same configuration or?
Yes. So if you plug in a USB device, take it out again and then plug it in later, maybe, could be a year even, we save this configuration, of course, and we identify the device by the MAC address.
Okay.
So it doesn't matter if you use a different USB port. This is also where the hot plugging is coming in quite handy. You can just plug it out and then put it back in somewhere else, and it just will be brought down automatically will be removed from the zone. Maybe the zone will be brought down if there is no connectivity anymore. If you plug it back in, everything is brought up again. That's how that works. So we just save that, we identify all the devices by the MAC address. The wireless devices will be identified by the MAC address, or it's not technically a MAC address, but by the address of the physical layer part of that device. So they are we can find them later, yes.
Am I able to add a device without having it already? So maybe a manufacturer tells me the MAC address and I'm able to add the device?
Not really.
Okay.
Is that something that's important to you? And I've never thought of that. So you could basically put in a configuration file there with the correct settings and that will come up, of course. But you won't be able to use the wizard, I think.
Okay.
Because we are checking if the device exists that you put there and all these things. So if this is, I can't really think of a case where this is really important, but if you can, just let me know.
Currently not, but maybe there will be one. So
you could have a client that would have, so you could be remotely working on a server install, for instance.
Yeah.
You have a remote client and they have all the physical hardware there.
Yeah.
You find out what the physical address of that device is.
Yeah.
And then when they plug it in, it just works. They'd have to do it.
Or you could let them plug that in
After.
and then configure that.
But yeah, if you, especially if you're deploying it somewhere in the back and beyond, you just want to configure it and let it go.
Yeah.
And then you don't have to worry about it afterwards.
So it will be easily implementable. We just didn't do it yet. So maybe we can do that. Everything I told you so far is just on layer 2 so far. So it's just talk about Ethernet. We haven't talked about IP addresses at all. And this is where the configs are coming in. So a config is just short word for the configuration on a zone that is adding layer 3 protocols. So layer 3 protocols can be IPv4 and IPv6. You can, of course, assign static IP addresses. The command is there. It just says config new IPv6 static. Then you put in the address and the prefix. You could also have a gateway for uplink zones. It's all written into a configuration file, configured on the zone if that's up, and then you'll have a static IP address on the zone. So that's quite easy what configurations do. This is also the most simple one. Just assign a static IP address on the zone and you have connectivity. So if this is plugged into some sort of network, I can ping this device now. That's what it does. And of course there are more complicated ones. DHCP, for example. We all want DHCP. Especially with IPv6, there will be a lot of dynamic network configuration going on. We haven't seen all the implementation of the providers yet, but DHCP plays a very important role in that. And the good part on our side is it's called host configuration protocol. So all the information that you need, like the gateway or IP addresses, is coming from the provider or from the DHCP server. The only thing that we need to do is just tell the device to start a DHCP client, and then we're good. So this short command just starts an IPv4 DHCP client here. Can you read that from over there?
That's okay.
Okay. So that's it.
So,
Yeah.
is it possible to assign several IP addresses to one network zone,
Yes.
or to a single port, which is a simple network device?
Yeah, you can do that. You can combine all the configuration hooks in all the ways you like. Of course, some configurations don't make much sense. If you have DHCP running, it doesn't make any sense to have static IP addresses. Except for BT Infinity, there's a forum topic at the moment where they want that, where you have a primary IP address assigned and then have static one. Well, you can combine them all so that, of course, it will make sense just to get configure a new configuration with an IPv6 DHCP client here, and as well you can configure IPv4 using DHCP, but IPv6 is statically configured then. So that's all you can configure. I think we still have some bugs with multiple IP addresses, but I think we'll be able to sort them out soon. So these two I showed you are the most important ones, I think. Apart from that, there is also IPv6 auto configuration. That's how the IPv6 address assignment works. There's a router broadcasting, multicasting in that sense, that it's there. It's announcing its prefix, and all the clients will automatically configure one on their network interfaces. That's what all the clients will do, but it's not very common for the firewall. It doesn't make any sense. There must be some sort of router, which is the first instance, always gets a IP address statically assigned. You can also not have any further information with that except the IP address and some DNS server. So if you use that for connecting to your provider, they can't tell you, well, the SIP configuration maybe, even the default gateway is a bit tricky. They all use DHCP, so I think this one will not play a big role in our case. And you can have a PPP OE server for IPv6 and IPv4. Well, I thought I don't need to mention this explicitly. Everything is IPv6 and IPv4, of course. So the PPP OE server was used to develop the PPP OE hook. So we set up two boxes, the one running the server, the other one running the client. That's why we developed that. And I think some people using that, other firewalls come with a PPP OE server option, and that is there. We can use that to play around a bit, and also for other things. I don't know really for what people use that, but it's there. So then you can have static routes. That's also being taken care of by the network tool. And you can also configure the DNS service there. We have that here because sometimes you want to configure static DNS servers, you want to use specific ones. And then you have, of course, all these different zones that may come and go, and they all are usually dynamically configured, and you get more DNS servers from your provider. So they are all put in a list and ordered by priority. That's why we put that into the network tool. There's of course the DHCP server. We need to hand out IP addresses to the network. That it's not probably a big part here, but it's quite simple to configure. But it's also managed by the network tool, and that's basically the end. So what you have heard is a short introduction, I hope, into how this tool works, how zones, ports, and configs work, and of course what all the other important features of this tool are. I hope that you were able to see why this was written. I also hope that you will see how the status of this is. It's, I mentioned that, still in alpha state. But I think we have all features in there so far, unless someone of you can think of something very important we have forgotten. So now what we need to do is just test and improve that as well as we can. And I think in the end this is a very, very important stepping stone in development of IPFire 3. It solves many of the problems we have with IPFire 2, and we choose not to extend the existing scripts because there's so much messy stuff in there, and well, this is the new shiny one. Okay, so that's all from me. More questions, please?
Are there any known side effects with having, say, 10 or 12 ports on one network zone?
Not really.
So it doesn't matter if you have one bridge, one DSL, 6 VLANs all connected to one network zone, and it will
Run quite smoothly, yeah, I think. There are some things that you don't really want to do if you have a very big network and you feel that the bandwidth on the firewall end doesn't really work anymore if you have just 1 gigabit and you put in more and more Ethernet adapters, and so that you get like 6 or so just to be able to connect all the clients on the network to each other. I think you're doing something wrong. So if it's getting too big, you shouldn't do that. The limit of that would be the hard work. That's basically it, I think. Apart from that, we have done some experiments with that. Sometimes we just did that for fun, creating multiple devices, just connecting them, like putting a bond on a VLAN and these kind of things. You can play around with them. It makes sometimes sense, sometimes it doesn't. Sometimes you are required to do that because you need to work around some older mistakes you did, maybe switch configurations where you can't really do anything else. I think that works quite well. There's just a limit where you shouldn't do things, I guess. So,
that sounds very complicated. One can do many mistakes with configuring this network zones.
Yeah, at the moment it's quite hard to do that on the command line. If we do that on the web user interface that we still have to write, I think that should be quite easy. I'm not really sure if we can make something like drag and drop. Yeah, probably not. But in the end, it should be very easy just to see what is in what zone and what can I do or what shouldn't I do. We can also have like warnings where there are too many interfaces in one zone. We haven't figured that out yet. But I think there's lots to do for the user just to make this simple. So I can show you some things. So we'll set up a virtual machine there. So on this machine, there is some random configuration on it. So what we have here is, let me quickly show you. This is a virtual machine that I use just for testing and playing around and fixing bugs. So there's lots of configuration here. Sorry?
Is there any graphical representation of the current network?
No.
So, okay.
Of this one? No. Well, we can edit this. So in this case, there is a zone called UPL6, which is a IPv6 tunnel service to 6xs.net, the tunnel provider. It's currently down. But there is one like these. There's also a bridge which is not really connected to anything because it doesn't have any ports at the moment. But it runs a DHCP client, which is of course very useful if you have no ports, and a PVPoE server, with these IP addresses. So that you can have these very different things, for example, on the same zone, and more zones. So what you also can do, if I can't really see the bottom of the screen. No, there it is. So if you type in network status and press the tab key twice, it will do this auto completion, so that we can easily see what zones there are. And just don't need to type that one. Okay, this one has 4 uplink zones. there's probably not much sense in all of them. So some are down, like the IPv6 tunnel. This one's up. This one is the primary zone that is also connecting this machine to the network. There is a DHCP client running on it. And it got an IP address assigned by the hypervisor. It's KVM, so it's one of the IP address in the 122 range. There's a single port here, and it's just connected. So what we could do now is we can create a new port. So now let's see if I can remember all the commands. So probably quite easy just to create a new dummy port, which is done by that. So if we do that a bit slower, you just can press the tab key twice so that you will see which commands are available. So there's the port command. You use the port command if you want to create or destroy any ports. Use, of course, the zone command to do.
Is the difference between devices and ports? I thought it might be the same. Or?
There's a difference. That is that ports are all these Ethernet-like devices. Mm-hmm. So these are like these. If you just print them. Oh, this one is not up. So like these, where you just have a MAC address that's all required for an Ethernet device, and on the device list there are all other sorts of ports there or devices, not only the ports, of course, all Ethernet devices, so all zones and all ports are devices, but there could also be the physical layers of the Wi-Fi devices. There could be serial devices and all these things. So there are also a few commands with the devices, so it doesn't make any sense here probably. What we could do, this is a virtual machine, so I can't have a Wi-Fi device here. There is the possibility just to start the monitor feature. Won't work on the other ones. It will create a monitoring device on the wireless link, so it listens to all the packets coming in on a certain channel, and you can see all the packets and use that for debugging. Not just the Ethernet packets, the 802.11 packets, all the Wi-Fi frames really. That's what you can do with these. There's also some discovery mode where you can say, okay, I have this port here, please discover what was connected to that, and it will send a PBPoE request or DHCP request and see what answers, and then it can be used to make a suggestion. If you set up a new firewall, plug in the cables everywhere, and then connect to the web user interface, we could show the user, okay, this is a DSL connection, do you want to type in your credentials? And then you just click OK, I want to do that, put in the username and the password your provider sent you, and you're connected. So we could have these things. Yeah, and you could also, the unlock command is used to unlock SIM cards if you have a PIN number on these. The USSD command is used to send USSD commands to the on a mobile network, so you can send SMS with that. You can also send these codes where your provider will tell you how much money is on your SIM card if you have a prepaid one, and where you could show a notification on the web user interface and say, okay, you're running out of money here, maybe. Yeah, sometimes the providers send you an SMS that your data allowance is running out, and you need to reply with a word like more or speed, I think it's with T-Mobile, and then you get another gigabyte or so. And I think we should kind of implement that too. Anyway, it's not one of the most important features, of course, but we can do that here. And maybe we can also do that automatically. So I wanted to create a new port. and attach that to that zone. For that, we just type in network, then port. It says that there are different ports, so if we have an existing port and we want to do anything with that, we just put in the name, so we can create it. That means create the device for maybe wireless devices. If you plug in a wireless device on IPFire 3, there will be no Ethernet device there. Usually you have a WLAN 0 device somewhere there. We just remove that. So you need to create these. You can bring it down, edit the configuration, of course, can print the status. And if you want a new one, you just have to type in new. And then there comes the name of the hook, which is dummy here. So we just created 2 dummy devices. What we need to do now is we can create these. So dummy device is also the same. I brought one of these up, which is D1. So probably a bit difficult to point there. Can you see the mouse pointer?
Yes.
Okay. We brought up the D1 device and IP link will print add none. Just ignore that here. But we didn't do the same thing with the D0 device. So these virtual devices need to be created sometimes for a physical interface. It won't do anything. So now we have both of them here. And then we can say network zone. Sorry, wrong keyboard layout. So we have different zones here. And then again we can say port, attach. And then we can also get a list with three ports here. So you can see that P1 is already missing because that is already assigned to that zone. And we can just add D0 and D1 like that. And then you can see, that, so what was the zone called again? That these are just connected to the zone. And that's how it goes. If we had a proper network connected to P1, there would be no downtime at all. No packet would be lost. It will just get added, and now you can have a different part of the network. So this is how that goes.
I think the network tool is looking very promising, but what I'm missing is a graphical representation of the zones I have, the ports I have, and how they are attached together.
We are accepting patches, of course. I forgot to mention that. So if you have any modifications, any new ideas, just implement them and send them away. You don't have that now. Yeah, I usually use the IP link or address command to see that. That's, it gets messy. It really will. That's not really a problem of our approach to that, because if you have a bunch of zones here and all the ports, especially the virtual one, you will have lots of devices. But that's how network is evolving at the moment. You will have multiple internet.
A short overview in maybe 2 seconds or something like that.
Yeah, makes sense. It really makes sense. I think that's a good idea. Yeah, we haven't implemented that. I have no idea how to draw beautiful things on the console, especially when it's scaled up and down. But I think it can't be too hard, and it could be very helpful. But the main thing will still be the web user interface, where we'll certainly need to have that. And I'm not really sure how many people use this, but I personally wanted to have a tool where I can do everything on the command line, and we can't do that at the moment. You just have to edit scripts and then restart everything sometimes, or make the changes manually. And if you do that and put it in the script later, you can't be sure that you didn't put in any typos there. Yeah, it's all a bit messy, and here you can have everything in one place and with just a very simple set of commands. So yeah, the commands get really long sometimes. You have seen there are many of them, but I think after a short time we will be able to learn that. And even so, if you don't remember them that well, you can set the host name and these things. It's all quite obvious, I think. There are settings and these. This is central configuration where you can just put everything in debugging mode. I also left the debugging mode in there because that's my development machine. And the blue messages you got there are just debugging messages. You can put in central configuration like the wireless regulatory domain, so that all your wireless devices will be configured appropriately and not send too much, send with too much signal and these things. Yeah. I don't know, but I think it's all quite easy, but we all need to get familiar with that. So, but if you want to change that, wireless regular should have batch completion for that as well. So, where we at? Okay, I can't type a. Oh, I can. There it is. Can just do it like that and just change the settings. And it should be there. Oops, it is. Yeah, you need to know where this is or that it's there. We have man pages for that. Oh, that's also quite interesting to show, I think. If you put in network zone, let's say, or just put in help. So in that case, if you just type in half of the command and then say help, I need help, you got man pages where it's all really explained. I think the auto-completion is a bit more helpful because after a while you can remember at least the most important ones. But if you don't, you get a man page with all the important things. So if you want to create a new zone, you can just see that the first argument must be the name of the zone, then the hook, and then any options that the hook requires. There could be credentials and these things. And yeah, that's all there. It's probably not completed yet. There might be chunks missing. I also don't know how well this is written, if that answers all the questions. But if it doesn't, just edit it, and then we'll have this documentation on the device. It's certainly not very user-friendly, but that's not really the target of this. This has to be admin-friendly. So we have it all there. No need to go to wiki or say. Okay, that's it then.